afternoon, everyone, and welcome to the first of a two-part chain event focusing on engineering behind COVID. I'm your host, Dr. Helen Mees. I'm a chartered engineer with the IMechE and a member of IPEM. I'm vice chair of the IMechE's biomedical engineering division, and I'm CEO of the medtech consultancy company, The Care Machine. Now, the effects of COVID have had wide-ranging implications on society, not just in terms of healthcare and infection control, but on the way that we live and work now and in the future. Engineers and engineering has been brought to the fore in a way only witnessed in the Industrial Revolution of the 1800s. And society is recognising the important role that we play in every aspect of their lives. Today, we are joined by two exceptional engineers who, through their contribution to biomedical engineering and technology, have been leading the way in saving lives and creating new environments for the betterment of mankind. I have the greatest of pleasures of introducing Professor Joe McGeough, a member of the IMechE since 1979 and an immediate past president of the institution. Joe is currently an honorary professorial fellow in the School of Engineering at the University of Edinburgh. His main field of research is manufacturing and especially unconventional electrochemical machining, where he has helped develop methods that could be applied in surgery, helping to establish an orthopaedic engineering centre at the Royal Infirmary in Edinburgh. His collaboration with surgeons has looked at the engineering analysis of back pain and the effects of age on the mechanical properties of bone. And more recently, he has chaired the institution's COVID response task force, which he's going to talk about today. Joe, thank you very much for joining us, and it's over to you. Okay, thanks very much, Helen. And thank you for inviting me to speak to the chain group today. I really am privileged to speak to you all. Special thanks to Nikki Valentine for asking me, and to Kirsten for arranging our rehearsals. And last but certainly not least, to my colleague Helen Mees, who's chairing the meeting today. Helen and I go back a long time. During my presidency, Helen was in the trustee board of the IMechE, and she and I would meet up there, and also afterwards, just when the epidemic broke out. And I know that Helen was very much involved in setting up the Nightingale hospitals in London. So there's the first slide. Look at the mission statement for the IMechE. Improving the world through engineering. And never has this mission of the IMechE been so important in the long time that the IMechE has been in existence. Just look at this slide, the slide on the right hand side there. Look at these. These are a depiction of the virus itself. They're absolutely tiny. Absolutely tiny. Look at the kind of spikes on the top. And those are the spikes that actually carry an infection. They're roughly about 20 nanometers in size, in length. The virus itself, the size of it is roughly about 100 nanometers. Bear in mind a human hair. The diameter of a human hair is about 40,000 nanometers. So you can imagine actually how small those viruses are. They attach themselves to anything around. And part of the fear with this particular virus was the fact that it would attach itself especially to any form of surface, including human tissue. And the respiratory tracts, the breathing faculties within the body, were particularly vulnerable to this particular attack. And that's why when they would cause sneezing, they would cause breathing difficulties, and things reported almost like pneumonia.
And that's why pneumonia was the perceived cause of the virus when it broke out in Wuhan. And that's why the treatments, washing your hands, face coverings, and keeping a safe distance. That's why actually those government guidelines are so important. On to the next slide then, please. So there we are. This really is a pandemic. The virus affected every corner of the globe and every person, every nation. And literally all around the world, members of the IMechE have been involved in actually in trying to tackle it. Helen helped to set up the Nightingale Hospitals in London. A senior member of the IMechE in Hong Kong was involved in setting up the hospitals in Hong Kong. And members of the IMechE working for Tata Motors in India. Tata Motors, they turned part of the production line to building ventilators. We had another member of the IMechE, Catherine Noakes, who deals with the environment and modeling of airflows. And Catherine became involved way back February last year, putting contributions into SAGE, the Scientific Advisory Group for Emergencies. We knew this was going on. Frank Mills, who deals with buildings, was involved. On the right-hand side, the presidents of the IMechE, of not only the IMechE, the other institutions, we were involved in almost weekly briefing meetings with government bodies, also looking for some form of guidance as to what to be done. And that covered virtually everything that was going on. Transport, modeling of how would hospitals deal. And we were invited to put in questions which would be answered or prepared for answer by government and other ministers. And probably one of the most revealing problems, and you're talking of February, March last year, was a group talking about vaccines. And at that time, there were no vaccines. And the three speakers there expressed their concern about how difficult this problem was, that it could take 10 years to produce a vaccine. And they were being asked to produce one within months. And one of the speakers expressed that this really had to be a worldwide effort. And the Oxford AstraZeneca virus is actually manufactured at Pune in Italy, in India. With all this going on, my successor, Terry Spall, phoned me up just a few days after he'd taken office and said, look, can we try to formalize what we're actually doing here? And it had been running from last March, and it was agreed I would chair it. And we went to the technical strategy board of the IMechE and said, like, you're the people with all the expertise. And from June, we had meetings every week for a full month where we tried to put this together. Again, the chain organization, part of your training, part of your education is to deal with some kind of situation for which there is no training or no precedent. And I certainly found dealing with the coronavirus was very much along those lines. Over the months, we were then being asked through the task force to put in reports to the Royal Academy of Engineering, to whom the government was turning for advice. We were putting in reports to the Department of Transport, dealing, for example, some of the questions that were coming. How would you deal with air travel, bus travel, Uber taxis? What would the form be for hospitals? What would the form be for hospitals for the future? And the Engineering Council got in touch with us and said, could we put on a webinar dealing with provision for buildings? And we were very fortunate to have somebody called Brian Kopp, who's a senior member of IMechE, who had been dealing with the Grenfell Tower inquiry, speaking about his experience of how to deal with buildings. On to the next slide. What is it? Okay, and again, this is part of the learning curve. We're dealing with this, a coronavirus. What is it? Well, it's an infectious disease. As I was saying earlier, it's tiny, 120 nanometers in diameter. And look at the size of that in relation to a human hair. Just shows how small it actually is. And this appearance, it looks like a solar corona, and that's how it got its name, of a coronavirus, the coronavirus. And between the technical strategy board, Jen Baxter, dealing with public relations at the IMechE, Frank Mills, and Catherine Hayes, we started to put together this scheme to see what we could actually do so worldwide. And the members for the task force came from the council, the trustee board, many international members, as well as the members of the technical strategy board. Next slide, please. By July last year, between Frank and Catherine and myself, we decided, look, we've really got to get some form of guidance out. And that's where the idea of a manual emerged. Could we put together some form of best practice to engineers and other parties? We were being inundated with questions. And we really got to kind of formalize this. How to make the workplace safe and how to travel. And you'll find when I come to it in a moment that that covers virtually every aspect of mechanical engineering practice. The second bullet point there, this is typical of the kind of guidance and information that we were being asked about. The Retail Motor Industry Federation came to us seeking for advice and clarification dealing with government legislation dealing with car washes. And this developed into one almighty battle. We soon found out that when I heard about it, that the legislation in England was different from the legislation in the other three home countries. And the day that I heard about it, I went round to our local Tesco to ask, could I use their jet wash? And the girl said, well, why not? Yes, of course, it's open. And back to the chairman of the retail industry, I said, well, they're open here. He said, but they're not open in Scotland. They're not open in England. And he explained that part of the problem was that automatic car wash, if you took your car to a car wash where you put in your credit card or your token or whatever and parked your car in the car wash, that was allowed. But if you took your car to a jet wash, and this one came from a car wash in Nottingham, in Northampton, that wasn't allowed. So we were involved in this dialogue as to what is automatic and isn't automatic. And again, some of the members, Caroline Koenig from Brunel, she was concerned that no, they shouldn't open. Somebody, Alan Bradley, from the aircraft industry, he said, well, they are taking precautions, but they've got to be careful. But if you use a coin or a token, that's contaminated. So these are the kind of issues that we were having to deal with. The Engineering Council got in touch, and we held a webinar for 2 hours dealing with just going back to the question of building safety. And that is affected virtually everybody. And Frank Mills spoke, Brian Cox spoke, and with 2 others, Helen Noak spoke, and one other colleague from Cambridge University who was concerned with buildings. On to the next slide. So putting together the manual, this is where we got to. And we decided we had to have information dealing with transmission of the building. And again, there's a section of the manual that deals with that. We were very much concerned and how transmission, how it actually happens. As I mentioned earlier, it deals with the spike on the coronavirus will attach itself to anything, and that by any form of breathing, you will breathe out that infection, and it's then coalesced into droplets. And when you breathe out, if you've got the infection, you're breathing that onto somebody else, and that's why face masks became so important. And the risk is low if you wear a face mask and the person who's listening to you wears a mask. But if you don't wear face masks, the risk is very high. And again, that's why supermarkets and some of the advice given to the car wash people, yeah, get people to wear face masks. Put that back to the government is one way to sort, and wear gloves and sanitize. If we go into buildings, again, my colleague Frank Mills was very much concerned with it, and he, right from the outset, part of his job is dealing with ventilation in hospitals, and Frank was brought in right away to the question of dealing with how to make hospitals safe. Locally here near, we kept in touch with some of the consultants in one of the hospitals, who by that time they were running the COVID ward. And I know they were changing PPEs 12 times a day. And at one stage they'd actually hit a brick wall. Air sterilization, Frank was concerned with ventilation. He was saying the ventilation is just not good enough, Air cleaning, and I'll come to these in a moment, but these were all, and that's why buildings, and that's why we've all been kept out of our own buildings for such a long period of time. The biomedical people in the IMechE, again, they came and they put in a very powerful document dealing with hospitals and masks in hospitals, the treatments going from there to oxygen being supplied if the patient was suffering, keeping airways open, and the most serious of the lot, to produce ventilators. And that's why ventilators became, and again, we know the Prime Minister had to go on a ventilator at one stage, and why the recent controversy with Dyson about making ventilators, and the government even put out a ventilator challenge. So concerned were they about the lack of ventilators in the UK for the problem. And as I mentioned earlier, the staff of Tata Motors in India had to turn to making ventilators to supply India, and don't they have their problems now? Transmission and masks, and again, that itself was a huge problem. Face masks, we soon discovered, actually could be in 7 forms, and probably the simplest form was simply a cotton mask that you make at home, or the kind of blue style masks that are commonplace now around the community. But the transmission comes in 3 main ways, either by touch. That's why we're not allowed to shake hands with people. If you're infected and you touch some form of even a supermarket trolley, that's why it's got to be cleaned afterwards. So these devices, and always think the government ministers, the medical advice people, they always look serious, and I'm not surprised. They're medics, you know, they're dealing with politicians. That's not an easy mix. They're also serious because their argument is, frankly, spell out frankly what the solutions are to this problem. We're then faced with an IMechE. How do we approach this? And thermal screening, we found out, was being tried out in police stations in the northeast of England, and that was based on what was being used with another epidemic in airports, and is still used to this day, checking to make sure if somebody's got a high temperature. And the police stations are still open, and the police stations installed thermal screening in order to screen people. If people came in with a high temperature, then they were usually shooed away or had to go and get a COVID test to find out what was going on. Thermal screening. Flying an aircraft. Again, with a powerful member, a senior member of IMechE, Andrew Bradley, who worked for the aircraft engine industry. And Andrew has a section in the manual dealing with flying. Again, the same kind of problems, same as we've got. How do you make the aircraft safe? And elementary things, you know, and using ultraviolet light to, and we found out that the virus is does not like sunlight, and therefore some form of ultraviolet cleansing was a solution. And again, we were concerned within the task force that ultraviolet can cause cancer, so therefore we had to be particular that the virus would be safe if you're going to use ultraviolet light. And it's a form of ultraviolet that's actually used to clean aircraft toilets. It is safe because it's got to be saved. And that was tried out by Etihad Airlines in the first instance. The units are made by Boeing and by Honeywell, big companies. Honeywell, big membership of IMechE. And there is now it's almost like a carry-on suitcase where the staff will use some form of ultraviolet to clean the seats in aircraft if people are going to fly. And again, another reason, and that's done within 15 minutes. So an aircraft coming in, they will have cleaned the aircraft using UV within 15 minutes in order to be used again. Management changes. Jeff from the IMechE has a very helpful section dealing with management changes. And again, like everybody else, people having to work from home or work outside their normal buildings. And I guess he said that's affected them. And he introduces, good rugby term, Scrum techniques and agile in sprints, holding daily briefing meetings, reviewing the situation. But what can you do externally that formerly you needed to do in the office? What can be changed? Again, Rob has produced some very, very interesting lessons for us all to continue to listen to. And again, manufacturing industries. Again, I still keep some collaboration with some colleagues in manufacturing. A lot of them work, but again, there's a section in the manual dealing with that. Changing over lead times, touching tools, touching parts that are made, touching the machines. How are they protected? What happens if a colleague doesn't come in? And the message that comes over, if they don't turn up for work, assume that they've got COVID, assume that they've COVID, and make sure that they get tested. So manufacturing industry, and that affects all of us here in the UK and overseas. And again, that's a very useful section. And here we are, and we decided to put in case studies. And Frank had been dealing with a hospital in Basingstoke, where they're using UV in order to clean it, to make sure that it's safe. There's a section on care homes, and again, care homes initially had a terrible problem with deaths, and care homes are now virtually entirely cleaned using UV in order to try to keep them safe. And again, this message: people still wear masks, and you try to keep away, social distancing, keeping away. And again, Birdcage Walk, the headquarters of the IMechE in London, now has demonstration units for ultraviolet cleansing facilities to be used. And again, one of our members who deals with the power industries, he's got case studies as how the power industry has dealt with how to deal with working from home and the practice that you've got to put in. So that's what's contained within the manual. And again, that took us from July and up till December, January, in order to put. And again, this was a major piece of work. The IMechE had never done anything like this before. And again, it needed a lot of agreement from the staff in order to try to put this together. And we're grateful to getting some young members helping us with the gathering the information together and putting it together in a form that people could readily use it. So on to the next slide, please, Kirsten. And there we are. So it's now been reformed. Again, it's been considered that my work was done. Frank had been running it from January. It was going to last a year. So we agreed it was time now to step down. But it's now being worked up now with the incoming president, offering continual professional development. This virus or forms of it will not go away. Updating the manual because when we wrote it, there were no vaccines. So that there are vaccines. So it's got to be updated. It's going to have its name changed from manual. But the Royal Academy and the Engineering Council are still back looking for information dealing with how to handle the next stages. And again, Patrick Vallance, whom you see in the almost daily meetings, the government go to the Royal Academy of Engineering and to the Engineering Council, and they in turn come to us at the IMechE looking for responses. So there we are. I want to thank Catherine Hayes at the IMechE. She worked with us, and again, it was hectic, trying to do this work, as well as the everyday job. And the IMechE still has to run. Still people need to be accredited. Others need their chartered membership. And Catherine stepped in and she helped us running. And Frank Mills, who's chairman of the Construction and Building Services Division for the IMechE, and Frank really, as I said, he really got this going way back last March. So I've stepped over my mark, but I hope you found it useful in terms of just hearing what the task force did and how the IMechE really was faced to improve the world through its engineering. Thank you.
Joe, thank you very much for that presentation. It's really interesting to hear about what the task force has been doing, and in terms of that, how difficult was it to bring together that many engineering experts, and you know, how do you go about building consensus to ensure that the information you're giving, particularly as you described to government, is accurate and effective?
Well, two things. I think that was one of the great achievements. We didn't know how this would work out, but right from the start, Frank Mills, he said, look, if we're going to run them, we've got to run them, these meetings, we've got to run them regularly. But we decided, we agreed, we would keep them to 1 hour, because people keep them to 1 hour. Just as you're doing, people's attention wanders. But also, we agreed we would have an agenda every time. So we would allocate between Frank and Catherine and myself. We would agree a time slot for every item in the agenda, so that people knew what they were dealing with. But the technical strategy board of the IMechE is, gosh, big.
Yeah.
Big. So managing that group, but we decided if anybody, we use the chat functions a great deal. We decided that anybody who wanted to speak could speak, but we would limit the time for what they spoke. So if they were going on a bit, we would cut them off. Not impolitely, but we'll let everybody speak. But some of the ideas that were coming out, but initially we got people to do presentations. Come and if you're from buildings. So we got Frank to speak about buildings. Okay, so Frank, can you do a presentation for 10 minutes, 15 minutes, 10 minutes, and then with questions? Could you, Andrew Bradley came and spoke, did a presentation about aircraft. So that's how we started to put the manual together. Catherine Noakes from Leeds, she came and spoke about the work with SAGE, and she is really an environment, a buildings control person. So she spoke about that, and that's how it's put together. But I would say, apart from, again, you always get people who can be difficult, and we had 1 or 2 difficult people as well with this one. But we decided to try and keep them to order. And they wouldn't dominate. We told them, you're going to speak, but you're not dominating this one. But most people were very constructive, because they realised how serious this problem was. But the remarkable thing is, members from Hong Kong to India to the Middle East to Germany, the European countries, and we had one presentation from Dubai, dealing with how the effects of that are in the Middle East. So that's how it was done. That's how it was done. Not easy, but we did it.
No, I think it's always very difficult when you get a large group of engineers in a room to get consensus. But I think in this particular case, it was very important to bring those experts in to be able to talk about their experience and understanding, and then to be able to use that to be able to create the document, which was really great to see. Now, I'm guessing that if you had a chance to do things differently, you maybe would. But is there anything that you would say that you would do differently if you were able to set the task force up again? The lessons that you've learned from this experience might help us, understand situations that we have to deal with in the future.
Yeah, as I say, that's a very good question. I think it really took us. I think we would have formalized the task force earlier. I mean, people didn't realize how serious. I don't think people realized how serious this problem was. And I think, and it really took. I mean, you were involved from the outset with the Nightingale hospitals. But I think if we had to do it again, there might be some other. I think we would bring in the technical strategy board earlier, because it really took us, from June. It really was the end of June before we kind of formalize it. And of course, we had to go to the chairman of the technical strategy board to ask, would they agree? And of course, he then had to put it to the technical strategy board. did they want to become involved? So I think we would do that a bit differently. But I think we would also be faster off our mark in dealing with the government agencies. I mean, quite quickly we realised they weren't coming to us right away. They were going to the Royal Academy of Engineering, and presumably they're going to the Institution of Civil Engineers and the Structural Engineers and the Chemical Engineers. So I think I would want to offer mark a bit quickly and say, to government, which are the government bodies? Which body? I mean, the government. I think there's something like, I think there was something like 15 professional engineering bodies. So therefore, they came to the Royal Academy, and a lot of the information that Valence was looking for was actually is still being channeled through them. So we do that differently.
Yeah, I would agree. I think there's what it has brought to light is that we need more engineers in these governmental and policy strategy bodies to actually be prepared to make these decisions very quickly, so that they can mobilize what is a huge body. I mean, if you look at all 38 engineering institutions, there's about 500,000 members across those professional bodies. When we were working with Nightingale, we ended up bringing in over 1,000 volunteers who were ready and prepared to get stuck in. And in the end, we didn't really need them, but it was the fact that they were there. And I think you're absolutely right, Joe, that having that presence has really been highlighted through this process, hasn't it? What would you, I guess this would probably be my last question, but you've had a long career in various engineering fields, and particularly in the healthcare sector. What would you recommend to young engineers, having gone through this experience with COVID, and obviously they have as well in terms of their own work, but if they were interested in coming into the healthcare engineering field in whatever capacity, what would you say to them to encourage them to do that?
I think for our, I know this is a cross engineering discipline, but it's interesting question. I gave a talk to, I think I'll answer this in this way. I told you my own experience of medical engineering was totally by chance. I'd actually damaged I'd been down visiting a big aircraft engine company looking for a new contract dealing with electrochemical machining, and I stumbled going down some stairs and I stopped. I didn't fall, but I felt a pain in my knee, and I'd obviously done, and I limped about at home for a couple of weeks until my dear wife said, "Look, I think you should go and see the doctor about this," who referred me then to see an orthopedic surgeon. And I came from just lecturing. I still, so any formal event, I wear a tie. So I'll wear a tie when I lecture to students, because if you wear a tie, people think you're smart. So I came from giving a lecture to see this surgeon called Mr. Christie. We didn't say, "What's wrong with you?" He said, "What do you do for a living?" And I said, "I'm a mechanical engineer." He said, "What do you do with your mechanical engineering?" I said, "Well, I work with metals." "What do you? What kind of metals do you work with?" I said, "Things like titanium." He said, "Oh, we like titanium here." So anyway, this is a long way, but basically I became involved in medical engineering because he said, "Look, I'll sort you out with your knee. But keep away from surgeons. Could you help me out with a problem I've got?" So if people are going to become interested in biomedical engineering, first of all, go to your local engineering institution, no matter what it was. Look to see if there's any talk that's dealing with biomedical engineering, and whether it interests you or not, go and listen to it. I gave a talk to the local IMechE here in Edinburgh about joint replacements, and unbeknown to me, one of our own undergraduates had seen the talk, who was a young member of the IMechE, just a student member. He'd seen the talk advertised, and unbeknown to me, he actually came and listened to it, and he said he was first he said he was shocked by some of the things that I said about implants breaking and aging. And anyway, he ended up doing a project, his honours project with me. And then after that, he got a job with a medical engineering company. So I think take an interest. That to me is probably the first stop. For those of you who, I know some of you are still working, those of you who are still at uni, if you see any seminars going on, just go and listen to what people say. Just hear what they say. In terms of my own experience, I found the clinicians they were very open to meeting students because they realized you were the future, and they would make times. Mr. Christie said, look, can you bring your students in at 10:30, 7:30 tomorrow morning? I'll take them in to watch an operation. And they were all there outside at 10:30. Gosh, that's a real, there's no sleepy heads this morning, Mr. Christie. So that's how you could, but I'll look, so if you like, again, I've said I'll do a talk, but if you want another talk through chain, I'll maybe speak to one of my medical people and see if he'll do a talk for you.
That sounds fantastic, Joe. I think that would be wonderful. Thank you so much for taking the time today to talk to us about what's been going on with the task force, and it just highlights how the engineering community can come together in this way to really use their expertise to inform serious decision making at governmental level. So thank you ever so much.
Thank you. Well, thank you very much. I'm privileged to speak.
Thank you. Now, our next speaker, unfortunately, is not able to be with us today, but through the magic of video and digital systems, we have got a recording both of his presentation and of a chat I had with him last night to talk about the work that he's been doing. Dr. Colin Kehoe is a mechanical engineer. He's a multi-award-winning serial entrepreneur, and he's currently based at the University College Dublin. He is absolutely passionate about problem solving, and his work in this in multiple areas such as biomass engineering, energy, 3D printing, additive manufacturing, and biomedical engineering, to name but a few. He is CEO and founder of the Rapid Foundation, which was born from a desire to create and support sustainable innovation around the world through disruptive open source technology distribution. Colin kickstarted an open source hardware project at the start of COVID with the Breeze Automation to produce a prototype ventilator using 3D printed parts and readily available inexpensive materials. The ventilator prototype was designed and produced in just 7 days. And after the project spun out, it went viral across Facebook and attracted participation from over 300 engineers, medical professionals, and researchers across the globe. So following his presentation, which we're going to play shortly, I pre-recorded an interview with him and asked him about the importance of distributed manufacturing and open source engineering.